Great. Could you please shut the door over there? Thank you very much. We are kind of 2 minutes behind the schedule, and the schedule is really tight. Okay, so I have 27 minutes. Let's go. Good morning, everybody. My name is Remigiusz Dudek, and I'm working as a trainer in code sprinters, and I'm also working in UBS through Loxaf in quite major Agile team. And basically all the presentation is about the experience we have learned through past couple of years. Okay, so let's talk about testing in Agile. So first of all, I'd like to talk about things that actually did not change, that are still valid even though we moved from classical environment to more Agile environment, right? So the software has exactly the same aspect as it had previously, right? We still need to take care about usability, performance, reliability, serviceability, maintainability, portability, so on and so forth. These things did not change. The only thing that maybe changed is that right now we just take a look at a story. We do not create a full test plan with all these different types of testing. We rather look at a story and consciously decide whether we will be looking at it from this particular angles or not, or we consciously decide not to test this particular aspect, right? But we still need to have these aspects in mind. Furthermore, previously we had so-called black box test case creation techniques, right? These are equivalence classes, border values, pairwise testing, orthogonal testing arrays, so on and so forth, right? We could just name lots of them. Okay, black box testing is kind of lame, but exactly the same techniques can be used while creating unit tests, while creating white box testing. This is a kind of knowledge that developers need to learn in order to create efficient unit tests. And these are things that testers already know because they've been working like that for past couple of years, right? So these are things that did not change. In terms of business knowledge, testers has always been perceived as kind of user advocates, right? We were always like that. But there is I'd say a one step forward. So right now it's not only that we are user advocates, it's rather that we are more of a business domain experts. It is crucial in order to be able to perform exploratory tests, in order to be able to ask valid what-if questions, right? You need to understand the mechanics of the business domain that you are working in. Otherwise, you will not be able to efficiently test your software, to efficiently find business border and corner cases, right? Which should also be probably covered in your application. Okay, and what is, I think, genuinely new is technical knowledge. So previously, testers probably did not have to be so much aware of the different modules, libraries, architecture our software had. But right now, we really do not have time for blindfolded black box testing. We need to be aware of the libraries we are using, especially those that has already been proven out there in the industry. If for example, we are using a transaction framework, right, based on a Spring, we need to be aware of that. Let's not test the features that has already been tested. We do not have time to waste. The only thing we need to do is actually to test the integration with this framework. But that's the only thing, right? But in order to understand, to see this small distinction, I need to be really aware of the technicalities of my software. And that's genuinely new work we as testers need to do, right? That's something we cannot escape from while moving to Agile environment. Okay, so let's just take a look at Agile testing pillars from a high perspective. So basically there are 4 pillars. It's unit testing, AAT stands for automated acceptance tests, exploratory tests, and non-functional tests, or so-called ALE2014 tests. Why ALE2014? It's serviceability, maintainability, reliability, and so on and so forth. Right? That's why it's called ALE2014 test. The thing is that these first 2 tests are really for the team. I mean, I'm really kind of surprised when I hear developers, or basically team, let's not divide team to developers and testers. I hear team being reluctant to implement unit tests or automated acceptance tests. Why? It is for them. It serves for them as a safety net, right? We are in Agile right now. I mean, I believe most of you currently work in Agile environment. So we are refactoring our code, right? A golden engineering rule, do not touch it because it's working, does not apply in Agile. We will be changing a code that is already working. And in order to ensure that this change will not introduce a regression defect, we need to have a kind of safety net. And unit tests and automated acceptance tests is actually the safety net that we have. That's the only way that we could feel safe while refactoring our code, right? The other two, exploratory tests and non-functional tests, are rather a test that it is not possible to automate, right? How can you automate a test that is supposed to check whether your code, whether your product is user-friendly? How can you automate it, right? Or how can you automate tests that actually you do not know what steps you will make, right? That's the exploratory test. When you actually derive the knowledge about next step, basing on the output of the previous step, you have really nice artificial intelligence applied over there to just make these decisions, which basically does not make any sense. So even though we are in Agile, which we really would like to promote automation in there are things that cannot be automated and still are crucial, are valid. Okay, so let's just deep dive into each of these pillars. First, unit testing. So what is the purpose of unit testing? Why we really want to unit test? So as I previously said, it's regression suite, right? So it prevents us from introducing regression defects, regression bugs, right? What's more, okay, a unit test is written on a class level, certain class level, so it precisely pins down the problem. It tells us exactly, okay, in which class you actually made a defect, right? Or even more, not in each class, but which business functionality, which business responsibility of this class is right now, in which business responsibility a class misbehaves, let's call it this way, right? And what is also really important in Agile is a feedback loop. So running a single unit test is is a matter of milliseconds. Right? In my team, we have right now like 14,000 unit tests, and it takes like 10 minutes, right? So running a whole suite together with AAT suite, it takes like 20-something minutes, like that. So we are able to perform a whole regression, 100% of regression suite within 20 minutes after introducing a change, which is, I think, a room for improvement. I mean, we may be better, this feedback loop may be even shorter, but it's not too bad as well. But what shall we actually do in order for unit test to really be a suite of a regression test suite? We need to think of a unit test as not as a test, it's rather a contract that this particular class presents to its collaborators. Just by reading unit tests, truly, you should be able to understand what are the responsibilities of this class, what are business context, what is the business context that this given class is being used in. You should be able, just by reading a unit test to your business analyst, this business analyst should be able to understand what you have just read and should be able to justify whether it is correct or it is not correct. Whether after a new feature being implemented, it is still valid or it is not valid anymore, right? And BDD proposes a kind of a format for unit tests. How many of you are familiar with should do something when something happens format? Great, guys, that's really cool. But and it's really important that we actually use it, right? And it is one of the pitfalls that is related to this format is that whenever you start writing unit tests using this format, probably you found yourself in a situation when, in order to describe all these branches and that are in the code, you need like tens of tests, right? And then it is really hard to read and memorize these tens of tests to understand what are the responsibilities. But that's actually a sign of a architectural flaw, right, that we have in our product. Right? That's a sign that probably this particular class has too many responsibilities and should be divided. Should not be doing this many things. Probably. No, I'm talking too much. Okay. Furthermore, okay, let's just focus a bit on the implementation details. I've seen a couple of times tests that are written using verify in order to argument captures features of mock frameworks. How many of you use actually these features? Just a couple of you. Okay. Please. Okay, so I will maybe explain what these features does. So basically, these features verifies whether a given class invokes its collaborators with particular arguments, right? That's what it does. And you see how tightly coupled to implementation and a unit test becomes. You are not testing a class behavior, but you are testing whether it is implemented in a certain way, right? Okay, and then you refactoring the class. Fair enough, you do it often, and guess what? Test fails. And what does it tell you? Well, it tells you that you have actually changed the implementation, as if you did not know it, right? It does not provide you actually any valid information, right? So just really think when you tied a unit test to implementation. Really think about it. Whenever your unit test starts to describe the implementation instead of business behavior of a class, right? Okay, so unit test should be rather a contract. And as a side effect of it, if we have all these branches in the code covered on a lower level test, then as a side effect, we as testers, we have a time to do more complex scenarios. Because I do not really have to take care of all these variations because I know that they are covered in there. So why do I have to do it manually? It's just monkey job, right? I don't want to do it, right? I'm created for higher purposes, not this kind of job. So having unit tests implemented, I am able to focus on more complex scenarios, right? Or on more complex scenarios from business perspective, or from technical perspective as well. Okay, so what are techniques that we can use in order to kind of facilitate this introduction of unit tests? So continuous integration, that's fairly obvious. I believe all of us right now are using continuous integration. So I'll more focus on this code coverage, because I believe that having 100% of code coverage is actually a must. 100% of statement and branches coverage in your code is a must. And I would really like to talk with whomever who disagrees with me during the lunch break. I would really like to this thing to be challenged us, as Steve just told us. Why am I saying it? It's because, okay, I understand that there are things that does not make sense to automate. I understand that. Like, for example, an empty constructor that we need to create in order to satisfy Hibernate's demand. Fair enough. But that's an exception. So let's create an exception, and let's not create a rule out of this exception. Let's not diminish all the other code because there is some exception. No. There are features to create exception, but the rule is 100% code, statement, and branch coverage. That's the rule. There are exceptions, but these are exceptions, nothing more. Okay. So what are the pitfalls? I've already said about this multiple lines of multiple tests that are needed to cover all the features, and it's so-called combinatorial explosion, right? Whenever you want to cover all the branches, all the paths, there is this combinatorial explosion of possibilities that you need to cover. But there are features to fight with that, right? We have parameterized tests, we have data sources, right? So there are ways to challenge that. Or there are different ways when you have a Boolean logic. There are also clever ways to test it. You do not need to test all the combinations in there. No, you do not, right? So it is possible to do it in a clever way. Okay, and let's assume that we have this 100% of code and statement and branch covered, right? It is possible that we will develop a kind of a false sense of security, right? And we do not really want our safety net to become this kind of safety net, right? Because then we can just, it is possible that we will just start feel cocky, right? Saying, I have all branches covered, everything is covered, I do not need any more tests, which is bullshit, right? It's not true. You do need another types of tests because not everything is to be automated, right? It is not possible to automate everything. Okay, let's talk a bit about automated acceptance tests. So what's the purpose here? So right now we just make a step higher, right? So we're not looking at a class, we're rather looking at a business requirement. So we'd like to cover all the requirements with tests, right? And not only this, when we do it, there are frameworks to do it, like JBehave, Cucumber, Spock. How many of you actually are using this BDD frameworks? Okay, just a third, one third. Cool. So probably you've also learned it. I mean, we've learned it, and it was a really hard lesson, that having only a scenario given when then is not enough, right? These are just scenarios. These are just small grains. But what you miss is a broader context. To be honest, right now in my team we have a great initiative to add narrative to all stories, to bring the business juicy context to all stories. Because a new person who comes into the team reads the test, and if it is only scenario given when then this person does not have this big picture. How it is possible that this person has this big picture if he is looking only on small grains, right? It's like looking at the image in the paper just from a really small length, I don't know, distance. Thank you very much. Okay, you just need to have a broader perspective, right? You need to be able to see this bigger picture, and that's what this business context is needed for. Okay, so tests serve as documentation. But in order for tests to serve as documentation, there is a piece of a job that we need to do. Okay, and by chance, it's just a side effect. It's not the purpose of automated acceptance tests, but they integrate your system. These are the tests that are usually made on an end-to-end level, right, from the highest perspective. And integration, we just have the integration for free, kind of, right? We do not focus on it, but it is there. Okay, there are different frameworks. JBehave, Cucumber, I've talked about it. Okay, the important thing is that in these stories, we are using a ubiquitous language. What is a ubiquitous language? It's a funny word. The thing is that we should use words that are understandable or understood by product owners, business analysts, engineers, right? Everybody should be able to understand it. Whenever you start to using a technical language in the story, you will end up in a situation when business will not read the story because they will not understand it. Developers or engineers will not read the story because they would prefer rather to read the code than the story, what the story is all about. That's not very bad, right? And we do not really want to be in this situation because we will lose this business description of responsibilities of our product. Okay. There is another nice technique, which is a specification by example. It's invented by a guy called Agile. It's really nice technique to translate a requirement into a test, just given when then thing, right? That's basically the main idea. Main pitfalls. Using technical language, I already talked about it. Using AAT on too low level. Every time when this idea comes to your mind, that you would like to use automated acceptance tests on some component level, think twice. Really think twice. Why not to use pure unit test there? There is a certain cost that comes with AAT, right? So, for example, when you're using JBehave, there are 2 files that you need to maintain instead of only 1, right? It is a cost that we will have to pay. So just think about it. I'm not saying that it should never be used, no, but just think about it consciously. Okay, and combinatorial explosion, it's again, here it can also happen, right? Especially when we have all these frameworks that I've just mentioned here gives us these features that allow us to test all the variations, right? Well, to give all this data providers or to use example tables, whatever we want to call them, does not really matter. But the thing is that we usually then test the same path, just testing a variation of one component. And that's not the purpose of these tests. We should not test variation within one component with AAT. That's the purpose of unit tests, right? These tests are long, complex, the feedback loop is not so short as for unit tests, hard to maintain, hard to develop. Why in the earth we'd like to do this to ourselves, right? Let's not harm ourselves. Okay, exploratory tests. 6 minutes left, man. Okay, let's just first imagine that we have, every test can be placed on kind of a continuum, right? On one hand side, we have scripted tests, which is every step is well defined, every verification point is well defined. We precisely know what steps we should do. If all verification points passes, test passes. Fair enough. On the other hand side, we have exploratory tests, which is I have a rough idea where I want to go, but I do not know the precise steps that I will take. The way I'm doing exploratory tests is I just run my application in a debug mode, put a bunch of breakpoints, and just go through the application, one step after another. And while doing it, and while preparing this this presentation, a nice analogy just came to my mind, which is, then walking through the application may be perceived as kind of a walk through a park. Right? You can see this nice bench over here, right? Nice design pattern. You precisely know what it is being used for, what is its purpose, right? What are its responsibilities? There is a nice cafeteria, cool, right? You can just walk through your code and everything is clear, concise, your business model is transparent, everything is cool. But in order to do it, back to these technicalities, as the tester, I need to be aware of such law as debugger, right? I need to. Okay, and I imagine that not every code would look like that. It is possible that you would rather find yourself in a jungle, right? That you just, the path is not really clear because multiple different frameworks are entangled together. You just came to some service and you just think, okay, how you'll behave? Will you throw up an exception on me when I behave like that? Well, it's not really clear. And in such environment, you really need some surviving techniques, right? Other way, you will just be confused, frustrated, and you will just mentally die there. Nothing. The exploratory test will bring pretty much no value. To be honest, my code is somewhere in between. I mean, in general, it is okay. There are just nice design patterns. Everything is nice and clear. But from time to time, you just come to such a creature and just, oh man, that's something new, right? You just need to explore it, just look at it from different angles. And that's how we learn. But please imagine, in my team, there are 8 teams, 6 people in each team. These are 48 people, right? Minus 6 because this is my team, 42 people. Developing a feature takes a week, let's say, on average. After a week of our changes, there are 42 person weeks of changes, which is almost a person year that other teams did. It is really crucial that we check whether this feature that seemed that have really value, that seemed really fine, that fits nicely to the concept, into the product, whether it really fits nicely after a person years of changes. That happens a week later, right? It's really quite important. So that's one of the purposes of exploratory tests, right? It's concept and idea tests. Whether the things that you've thought a week ago are still valid after a person year of changes that other teams did. Right? That's one thing. You also need to check whether a business model that you have actually changed or enhanced, whether it is still concise, whether naming conventions are preserved, whether everything is clear and nice after your change, right? And that's what you do by debugging your code, by looking through your code, walking through it, and just looking around, basically. And of course, you are also Lots of questions will rise while you'll be doing it. Lots of questions like, what if, right? What will happen if actually this user was a VIP user, or would have this attribute being set to this value, right? Because there is this strange if that actually checks that. So why is this if there, right? Lots of similar questions would appear when you start doing it. And this is how we come to business border corner cases. In order to ask these questions, we need to be able to understand this mechanics of the business domain, right? To ask valid questions. Okay, and as this model. Okay, and as a side effect, you will get the architectural knowledge of your system, right? You will be able to start asking a valid questions, not only from business perspective, but also from technical perspective, right? You will know the technical limitations of your software, right? So hopefully your architecture does not look like that, but it may. Okay, so what are the main techniques? The main techniques, as I already said, what if questions, but in order to ask valid what if questions, we need a really broad understanding of your business domain and debug. That's how I learned my software, to be honest. And the biggest pitfall I have fallen, especially, and when you start doing it, you will fall into this trap. You will get lost in the meanders of your project. None of us knows our software 100%, probably nowadays, especially. So you will be lost in it, but you will learn constantly. So that's something that can be or can be defeated with time only, I believe, and with experience. I mean, that's how it was in my case. And the last slide that I never intended really to cover, because these are things that actually did not change, right? Non-functional tests. We still need to take care of performance, security, volume, scalability, interoperability, and so on and so forth. It did not change, so I don't want to talk about it. Thank you very much. If you have any questions.
Open space.
Okay, thank you very much.